example 1 asks us to solve the inequality 2x squared minus 5x minus 12 is greater than 0. So we have 2x squared minus 5x minus 12 is greater than 0. What I want you to do when you're looking at an inequality is think about this as two parts. Like you have a line that is cutting off your equation. It is not allowed to be either above or below a certain point. So if you can visualize what's going on, it can help you solve our problem. Well, this equation here is a positive 2x squared, which means that we know that our graph is going to be facing up. It's a parabola facing up. So three things are possible. Either one, it never intersects the x-axis at all. Two, it intersects at one place only. Or three, it intersects at two. So we could end up here with either the entire, all real numbers would be greater than 0 here. We could end up with every place except one, the place where it is 0. We could end up with just one place where it doesn't exist, or we could end up with an interval. Like in this case, we have this small section under the x-axis would be where it doesn't work. So really what it depends on are what are the zeros or the x-intercepts for this particular graph. That's what you need to focus on here. And then just use a little analytics here, understanding what it looks like to kind of answer the rest of the problem. So what I want to try to figure out is what are the zeros for this function. So in order to do that, you have to think about this graph like an equation, but it all goes back to this original one. So if I were to say 2x squared minus 5x minus 12 equaled 0, if I said that was true, then I need to use either the quadratic formula or completing the square or factoring in order to find what the zeros are for this. So I'm going to factor. I know that because of the 2x squared, I'm going to end up with 2x and x split that way. And so I need to find two numbers here that are going to multiply together to make negative 12 that will go back with its partner on the other side to make 5x. So we think here, if I do let's see, positive 3 and negative 4. If I do positive 3 and negative 4 in this place, this will make 3x, and this will make negative 8x, and that will combine to make my negative 5 that I'm looking for. So this is a little bit more complicated factoring. So if you want to use the quadratic formula, you're completely welcome to, and you'll get the same answers. From this, I know that either 2x minus 3 is going to be 0, or x minus 4 is going to be 0. And I can solve and say, okay, well, this is going to be x equals 3 halves, or x equals 4. So these are the zeros of my graph. So I can kind of, this would be negative 3 halves. So I know my graph, what it's going to look like, is going to be, I'm going to have two intersecting points. And so we'll have, this is the negative 3 halves, this is the 4. And so before it gets to this point, so imagine my graph, I'm kind of coming down with it and coming back up. Before it gets to negative 3 halves as an x, so when x is less than negative 3 halves, that is, it's going to be positive. And then when x is greater than 4, which is after 4, it's positive again, that also gives me a solution set. So both of these answers together are going to answer my initial question. Now you can graph this out and you can kind of see, like, sometimes people like to do the solution sets like this, where you kind of have like 0. You can have, -3/2, 4, and then you can create kind of a line chart for it. Now, for this one, we would have an open circle because we're not allowed to be -3/2. We have to be less than -3/2. And then we would have to be greater than 4. So either of those two representations would be completely legitimate. I would like you to write this out, though, first, just to show where your work came from.